For every 7 flowers, you will get... Hello, mathematical literacy learners. Welcome to question 3. Eastern Cape 2021 September paper 2. This is still a continuation of the requested video. It's one long video. Anyway, we are looking at this cake over here in the box, and let's read the statement first. Mr. Jonathan and his wife decided to arrange a birthday party for their only daughter. They purchased 2-layered round chocolate cake at the bakery. The cake has 2 layers. The diameter, which is the distance from the beginning of the circle all the way to the end of the circle, and that is of the bottom layer is 250. So this distance over here is from the beginning to the end is 250 millimeters, and the diameter of the top layer, now this one over here, is 18 centimeters. Below are pictures of a 2-layer cake, 2 layers, and they said the chocolate cake is round. And a rectangular cardboard box, so the cardboard has a length better than a height. It's a rectangular prism. Then note that the diameter of the cake top layer is 18 centimeters. Okay, so the diameter of the cake with the bottom layer is 250 millimeters. This one is also 250 divided by 10, which is 25 centimeters. That one, 18 centimeter divided times 100 times 10, that would be 180 millimeters, just in case we need it. Area of a circle is equal to pi r squared. Now we need a radius to calculate the area of any of these circles. So we have a diameter, so we're going to have to divide this by 2 to get a radius, divide that by 2 to get a radius. Volume of a rectangular box, length times width times height. Again, here we're given length in millimeters, or it can be 40 if you divide centimeters. This one can be 300 millimeters. In case they say calculate in centimeters, calculate in millimeters. Okay. And then they tell us that 1 inch is equal to 25.4 millimeters. So this is my conversion factor, which will help me with cross multiplication. Refer to the diagram above and answer the questions that follow. 3.1.1, determine A, the area. So that, now determine the area indicated on the top layer of a chocolate cake in square millimeters. The top layer is circular. There's the area of a circle, and they say you must calculate the area A, and then they're pointing out where that is. So they want the area of the space here at the top. Give your answer to the nearest whole millimeters. So we're calculating the area of a circle. Area of a circle is also area of a circle is equal to pi radius times radius squared. Okay, am I tired or something? Okay, so now let's identify our unknown. The question says calculate the area. Therefore, area is our unknown. And they're saying make sure that your answer is in millimeter squared. Let's go look at it again. They say calculate the area, and then make sure that the area is in milliliters squared. They said calculate the area of the top layer. So we're going to calculate the area of this top part here. Area is equal to pi times radius squared. Okay. So now what we're going to do is we're going to say we are calculating this is our unknown, and then pi is 3,142 times the radius. So our radius is what? Then now let's go back and say our radius is, oh, we don't have radius. We're given 18 centimeters is the diameter of the top layer, which is, we're given the diameter. Now, what is the radius? Radius is half the diameter. So what we're going to do is we're going to break the diameter into two and get half of it, which is the radius. So what I'm going to do is I'm going to say 18 centimeters divided by 2, and I'm going to get 9 centimeters. Then I'm going to say, they said it must be in millimeters squared. Therefore, I cannot work with this. I'm just going to convert it to millimeters. So now I'm going to say 9 times 10, and that gives me 90 millimeters. Then I'm going to substitute. So A is equal to 3,142 times the radius, which is 90 millimeters squared. I forgot and did this with the diameter first, and then I was like, what? And then A is equal to, then now we're going to say 90 squared, which is 3,142 times 90 millimeters squared, 8,100 millimeters squared. Then we're going to times that with 3.124142. I'm not used to this calculator. 3.142, and that is A is equal to 25450.2 millimeters squared, and then A is equal to, now what I'm going to do is I'm going to go back and check anything about rounding on the question. Give your answer to the nearest whole millimeters squared. That's fine. 25450.2. I'm just going to copy it down because I want to do it again. So now I look at this number, and then this is one. So they don't want any commas. Is equal to 2545. And then what happens to the 0? It stays the same. And the number ends like that. So if you don't know what happens is like the comma, what happens to the 0 now as 0 is there. So this is 254,0 millimeters squared. Okay, now what happens if you substitute in centimeters, and then you get your answer, and then you convert your answer? So if you were to say area is equal to pi times radius squared, and then you say area is equal to 3,142 times a radius of 9 centimeters. Still have to divide 18 by 2 because that's a diameter. And then you say squared, and then you say 9 squared. You get 81, which is 3,142 times 81 centimeters squared. And then you multiply that by pi, which is 3,142. And then you get 254,502 centimeters squared. Now you have to change this to millimeters squared. Now remember, yes, we're changing centi to milli, but we're changing centimeter squared to millimeter squared. So what do? We say 254.502 multiplied by 10. Then we say it's not centimeter, it's centimeters squared. Therefore, our 10 is also going to be squared. So our 10 must reflect that we are now converting an area, not a distance. And when we're converting a volume, we say 10 to the power 3, right? And then you say 10 squared, just so 10 times 10, and that is 254.502 times 100. And then you say this times 100, 254.502 times 100, and then you get 254,502.2 millimeter squared. Then you round off, of course, according to the instruction on the question. A ribbon will be wrapped around the circumference of the bottom layer cake and must overlap by 50 millimeters. Calculate the length of the ribbon in millimeters. Okay, so a ribbon will be wrapped around the circumference. Remember, we talked about circumference. We said the circumference is the total distance around a circle. So the ribbon will be wrapped around here. So there'll be a ribbon wrapped around here, going all the way, covering the total distance around. And then they say it's going to overlap. There's going to be two overlap. It's going to sit like this by 50 millimeters. So let's find the total distance and then make it overlap. Okay, so the formula. So let's see if the formula includes the overlap. It does not. It just that this is just the total distance around the circle, which is the circumference. There's no plus 50, which is the what is this thing? Which is the overlap. Okay. And then they said that we must calculate the length of the ribbon in millimeters. So everything must be in millimeters. So I must make sure I'm calculating in millimeters. No problem. Okay. So let's start. We're going to start by calculating the circumference. Therefore, we're going to copy the formula. Circumference is equal to 2 times pi times radius. Okay, now let's go and look at the unknown. The question says calculate the distance around and then put an overlap on it. So that's the circumference. That's our unknown there. And then we have 2, we have pi, which is 3,142, doesn't have a unit of measurement. And then we need the radius. We're going to find the radius somewhere here. Or we're not given the radius, but we are given the diameter. Whenever we have the diameter, again, noise. It's 250 millimeters. We can use the diameter to find the radius. So what we're going to do here is we're going to say 250 divided by 2 is equal to 125 millimeters. And then we are going to substitute. Circumference is equal to 2 times 3,142 times 125 millimeters. And then we press our calculator. 785.5 millimeters. So this is the total distance around the circle, like that. So now we need to add the overlap over there so that we have an extra piece of the ribbon over there so that they can be glued together. Okay, now we're going to say length of ribbon is equal to 785.5 all around the cake plus the 50 millimeters. So it's just going to add 50 milliliters here and we get 835.5 milliliters. So now it says the volume of a rectangular box is 42,000 centimeter cubed. Now, before we go to the box, I just want you to think, what would have happened if they just gave you this information and they gave you and all the other measurements that you need to calculate this, but didn't draw the box for you? Would you be able to imagine the box? Just asking, you know. Okay, so the volume of a rectangular cardboard box is 42,000 centimeter cube. Determine the height of the box in centimeters. Now the volume, what is the volume? The volume is the space occupied by a 3D shape. So I like to say it's the total space inside the container, but you can say it's a space occupied by a 3D shape. So a 3D shape has a height as well. It's not like a 2D shape, which is only flat like this. These are 3D shapes. They've got height. So when we talk about a volume, we talk about something that also has height. Okay, so now let's come back here. We have this box here, and they're saying here the volume of this box is equal to 42,000 centimeter cubed. That's what they say. We have calculated the volume. Now they say determine the height of the box in centimeters. Now you have to go back and say, hey, wait a minute. They gave me the volume, and then they say calculate the height. How do they get the volume without the height? That's the question you should ask yourself. And then you go to the formula, say, how did they get the volume? And then you say, oh, they used this formula. So can I use this formula to calculate the height? Okay, so let's check what we have. If you only have one unknown here, then you can use this formula. Let's check. Height, we don't have. Width, we have, there it is, 30 centimeters. Length, we have 400 millimeters, but don't substitute units of measurements that are not the same. Make sure they're the same. Volume, yes, we have the volume. There it is. It's given to us as 42,000 cubic centimeters. We can get the height. So let's go and use the formula that they use to calculate the volume. We are going to use it to go back and get the height. So volume is equal to length times breadth times height. Okay, volume is, okay, we have the volume. Let's go get the volume, 42,000 centimeters. Wait, let's first identify the unknown. The unknown is height. How do I know this is the unknown? The question says, calculate the height. It means you don't know the height. Okay, so what do we know? We know that volume is 42,000 centimeter cubed. And we know that the length is 400 millimeters. We know that the width is 30. So we have the volume, yes, 42,000. Do we have the length? Yes, it's 400 millimeters. We have to change it to millimeters, to centimeters. And then we have the breadth. We need the height. See? Okay, so before we do anything else, let's just change the thingy. So I'm just going to change the length. So we have 400 millimeters. We're going to change that to centimeters. And then how do we do that? We divide by 10. We get 40 centimeters. Now we have everything in centimeter. Our volume is 42,000 centimeter cubed. Then you get is equal to, then you get length, which is 40 centimeter. Now that we've converted it from millimeter to centimeter, then you multiply by breadth, which is width in this case. Did I copy it wrong? Does it say width there? Oh, it says width. So let me write width just for this purpose. Okay, width, and then that is, our width is 30 centimeters. Then you multiply by the height. Do we know the height? No. So let's just continue writing height there. Now, there are these two numbers. They multiply each other. Let's go ahead. We know that we can multiply numbers with each other. So we have 42,000 centimeter cubed is equal to, what is 40 times 30? That's 1,200 centimeters squared multiplied by the height. If you like, you can leave out the units of measurements and just write them at the end. I like to include them sometimes when I don't feel like it, I don't. So now I have height multiplying 1,200. How do I make sure that height is sitting on its own? I'm going to look at what they're doing to each other. They are multiplying each other. Let me do the opposite. So we're going to do the opposite of multiply, which is divide by 1,200 centimeters squared. What we do this side, we're going to come and do this side. So 42,000 divided by 1,200, and you get 35 centimeters is equal to our height. 1.1.4. Mr. Jonathan's cousin in England claims that the diameter of the bottom layer cake is more than 10 inches. The diameter of the bottom layer cake is more than 10 inches. Verify with the necessary calculations if the claim is valid or not. Let's start over. Mr. Jonathan's cousin in England claims that the diameter of the bottom layer cake is more than 10 inches. 10 inches. We don't use inches. Verify with the necessary calculations if his claim is valid or not. Okay, they're saying 10, the bottom layer of this cake is 10 inches. Okay, let's go find out what the bottom diameter is. The diameter here is 250 millimeters. So how do we know that it's more than 10 inches or not? We have to convert it to inches first. Let's see how long it is in inches. Okay, so we're going to say 1 inch is equal to, and then we're going to use the conversion factor, 25.4 millimeters. 25.4 millimeters. And then we're going to say is equal to, and then what do we have? We have 250 millimeters. We don't know how many inches it is. And then we cross multiply. 1 times 250 millimeters is equal to unknown times 25.4 millimeters. And now we have it like that. Then we divide by 25.4 millimeters. Boom. And then we divide by 24.4 millimeters. 25.4 millimeters. Let's see. That is 9.842519685 millimeters. And if you round off that, it will be 10. So let's round off. So there's no way this is more than 10 inches. Huh. Why don't you say anything? That's inches there. Okay, that's inches. That's 10 inches. Okay, now let me check again. Mr. Jonathan's cousin in England claims that the diameter of the bottom layer cake is more than 10 inches. False, false, false. It is actually less than 10 inches. But if you round it off, it will be 10, but it will still not be more than 10 inches. Not valid. According to the baker at the bakery, the height of the bottom layer of the cake is 64% of the radius. Calculate the height of the bottom layer of the cake in millimeters. Now we're still going back to the cake. The height of the bottom layer of the cake is 64% of the radius. So the bottom layer is, the diameter is 250, and the radius, 250 divided by 2, the radius is 125 millimeters. And they're saying that if you multiply this by 65, and then you will get the height. No. If you multiply this by 64%, you will get the height of the cake. No problem. So we have the diameter. That's what we have. We only have the diameter, which is 250 millimeters. It's written right there. The diameter of the bottom layer cake is 250 millimeters. So that's what we have. So that is 250 millimeters. Now they're saying the bottom layer is 64% of the radius. So let's first find the radius. How do we find the radius? We're going to say 250 divided by 2, and we're going to get 125 millimeters. Now, we have the radius. We need to get the height. So the height will equal to 125 multiplied by the 64%. It is the size for 64% of the radius, and that is 80 millimeters. And then we go to 3.1.6. The recipe for the chocolate cake needs flour to sugar. flour to sugar, flour dot sugar, and in a ratio 7, flour dot 3 sugar. Right? Determine the number of cups for flour needed if 6 cups of sugar are used. Okay, so here's what we have here. First, what do we have? We have flour, which is not known, and then we have sugar, which is 6 cups. So the actual cups is 6. So what we're going to do is we're going to say how many, now they want to know how many flour. Now, the ratio says 7:3, right? Flour and sugar. For every 3 sugars, you get 7 flours, right? So 7, flours. For every 7 flours, you will get 3 sugars. So now what if I have 6 cups of sugar? How many flours will I get? And that's 7 times 6 is equal to flour times 3 sugars, which is okay, let's go again. We say here, we have a ratio which says 7 flours and also 3 sugars. So for every 7 flours, I need 3 sugars. This I know, right? This I know from the ratio. Now let's see. In real life, for every flour and every sugar, so they say, hey, we have 6 sugars. They say, hey, we have 6 sugars. How many flours? Say, okay, we have 6 sugars, and I don't know how many. Then you cross multiply. 7 times 6 is equal to unknown times 3. And then you say divide by 3 this side, divide by 3 this side, and you get your answer, which is 14 flour unknown, which means 14 cups of flour. Now let's come back to the let's come back to it again. Now don't confuse this with the one where they give you the total of all the cups of sugar and flour together, and they say for every cups of flour you get this much sugar, and then they say how many flour, how many sugar, and then you get the total. That's not that question. We do not have the total cups here, right? So we can't use that. We can only use this 6 and the ratio, right? So take the ratio as a conversion factor. Go and write the part for sugar under the side for sugar, cross multiply, and you'll get your flour. Man's wife plans to bake a similar 1-layer chocolate cake for a tea party. She received the recipe from a friend in the United Kingdom. According to the recipe, the baking temperature should be at 365 degrees Fahrenheit. Now determine the temperature in degrees Celsius. So they want degrees Celsius from this Fahrenheit, and they say give your answer to the nearest 10. So we're rounding off as well. So let's start first by changing Fahrenheit to degrees Celsius, and then after we will round off. So we can convert using the formula. That means the first step is to copy the formula down. In grade 12, I'm pretty sure you're good at this now. So we're just going to do it fast. Okay, so degrees Celsius is the one we're looking for. Fahrenheit, let's go back and check. 365 degrees minus 32. And we say divide by 1.8. And then we're going to minus inside here first. We're leaving no one behind. Just in case you're still struggling, this is 333. Then we're going to divide by 1.8. So divide that by 1.8. And now we have 185 degrees Celsius. Right? Our unknown is 185 degrees Celsius. Now the question says round off to the nearest 10. Right? Okay, let's round off. 185 degrees Celsius. Nearest 10. Units, tens. Oh, this is where we're going to find tens. And then we look at the neighbor. Then we say this 1 is not affected. Then if we look at the neighbor, what is the neighbor saying must happen to 8? 8 is going to increase to 9. And then, wait, why we had 185, now we have 19. So 5 now is what? Is a 0 there. We just hold the space with a 0. And then it's degrees Celsius. Boom. Very easy, né? Okay, moving on. Okay, so here we go. Tree diagram. This is not a 3 diagram. This is a tree diagram. Mr. Jonathan and his wife plan to have 2 more children. Study the diagram below. Mr. Jonathan and his wife plan to have 2 more children. Okay, they already have a child. They're going to have 2 more. Now study the diagram below. Child is a girl. Second child is a girl. Third child is a girl. Or first child is a girl. Second child is a... Third child is a girl. First child is a girl. Second child is a girl. Third child is a boy. First child is a girl. Second child is a... Well, that would be a boy. That should be a boy over there. And then girl, boy, girl. Girl, boy, girl, boy. Okay, first child, boy. Second child, girl. Third child, girl. First child, boy. Second child, girl. Third child, boy. First child, boy. Second child, boy. Third child, girl. First child, boy. Second child, boy. Now that's a perfect combination. Third child, boy. Now let's see. 3.2.1 says identify the type of the diagram shown above. Well, that's a tree diagram. T-R-E-E, tree with leaves. So, okay, so 3.2.2, write down the appropriate items for P and Z. All right, so Z will be boy, girl, boy, boy. So first child will be a girl, second child will be a boy, third child will be a boy. Okay, that's the answer there. And then 3.2.3, determine the probability for Mr. Jonathan and his wife of getting at least 2 girls. And then you must write it as a fraction in the simplified form. Let's go find out how many girls, at least in any random order, because they didn't say what order. No girl. Oh, this is 3 girls. 2 girls. This one is the one they're asking for. 2 girls. Girl, boy, girl. That's the one. This one has 1 girl, 2 girls. This one has 2 boys. This one has 2 boys. This one has no boys. 3 chances of having 2 girls. Let's go again. 3 girls, 2, 2, 2. It's 3 chances. This one, I think it's 3 out of 8. And then this one getting a boy. So it must be first a boy, then a girl, then a boy. So this is going to come from here because this is the only part that has a boy as a first child. And then a girl, that's the one. And then a boy, that's the one. So that is 1 chance of getting a firstborn boy, then a girl, then a boy. That's 1 out of 8. 1 out of 8. And then you have to write this as a percentage. So you have to divide it by 8 and say 1 divided by 8. And that's 0.125 multiplied by 100 to get a percentage. And then it's 12.5%. Now, remember, percentage can be written as a fraction. Fraction can be written as a decimal. And decimal can be written as a percentage. And so it goes on and on and on.